Hello, Colin Holmes here, and today we're going to be talking about proving parallelograms. Last time we actually talked about the qualities and the properties of parallelograms, but this time we're actually going to show if a quadrilateral is a parallelogram. Now, one way of doing it is obviously by the definition of it. Just by pure definition of a parallelogram, that's a parallelogram. And basically, we're not gonna rewrite the whole definition as much, other than the fact that opposite sides are parallel. And I'm putting in parentheses both. That's the big key. Both sides has to be parallel. Just by pure definition. That's one way. Another way is through the converse of opposite sides, which, remember, converse is when we take the if and then statement and then switch them. So, if both pairs, let me rephrase that, both pairs of opposite sides are congruent, then it's a parallelogram. Okay? So, if we have both sides being congruent to each other, then no matter what, it's a parallelogram. Alright? So next, we have opposite angles theorem. If both pairs of opposite angles are congruent, then it's a parallelogram. Okay, so the same idea works for opposite sides, except now we're dealing with angles. Opposite angles are congruent to each other. Next, we have the converse of diagonal lines, which basically states if diagonal lines are congruent, if diagonal lines, if diagonal lines bisect each other, then it's a parallelogram. Alright? That's the big key. If we have diagonal lines that bisect each other, then it's a parallelogram. And the big key is they both have to bisect each other. Both diagonal lines have to bisect each other. Next, and this is kind of new, we haven't heard this statement before, is one pair parallel and congruent. We haven't talked about this yesterday, but this is something a little bit new. If one pair of opposite sides are both parallel and congruent, then it's a parallelogram. Alright, so if I have one pair that is not only congruent but parallel, then we have a parallelogram. And it doesn't matter about the other side, they just have to be both. If we have both parallel and congruent for one opposite side, then it's a parallelogram. And the same will be true for the other, by default. So next, we want to go ahead and solve for x and y. We want to solve for x and y in order to prove that it's a parallelogram. So I look at this. I can't really, to be honest, just looking at it, I can't really figure out a way to solve for y because, well, they're both 2y and I don't really have a value for it. But I can solve for x first. So I know that these two are congruent. So 2x minus 60 equals x. I want to subtract 2x from both sides. Negative 60 equals negative x. How do I get rid of the negative? Divide by negative 1. So x equals 60. So I just solve for x. So I know that this is 60 right here. This is 60 right here. But now, if I want to solve for y, remember, consecutive angles theorem tells us that they're supplementary. So if I can take 180, subtract it from 60, I get 120. So I know that this angle is 120, that angle is 120. So it doesn't matter which one I solve because they're both the same. 120 minus equals to 2y. I want to divide by 2 to both sides. Y equals 60. So a very rare case that both x and y happens to be the same number. This is not always going to be the case, but this is just the one coincidence. Alright, just be aware of that. Next, I have this parallelogram, but it's dealing with opposite sides. So for one pair of opposite sides, I have 3x plus 6 equals y plus 4. And then I have 3y minus 9 equals 2y plus 2. I can't solve for this because it's one equation with two terms. That doesn't really work out. I can't get anywhere with that. But I can solve for y because I only got one variable with one equation. So I want to add 9 to both sides. So I get 3y equals 2y plus 11. Subtract 2y from both sides. And I get y equals 11. Well, now that I know that y equals 11, I can replace this y with 11. So it'll be 11 plus 4. 11 plus 4 is 15. Subtract 6 from both sides. 3x equals 9. Then I just got to divide by 3. X equals 3. Okay? So, biggest thing we got to remember is that the four things. Other than definition, which basically states that both opposite sides are parallel, we also have the fact that opposite sides are congruent, opposite angles are congruent, both diagonal lines are going to be bisecting each other, as well as if I just have one pair of opposite, if I'm looking for one opposite sides, if they're both parallel and congruent, then that gives me a parallelogram. Thank you and have a good day.